So now I'm going to go to the next question. The next one is actually a sequence and series question. It's a beautiful question. And then it is actually one that was sent to us by Tebucho Muchawe. And it's beautiful. It's got a lot of very exciting concepts that you're going to be looking at. Remember, when you're doing sequence and series, there are 3 things that you need to keep in mind. Sequence and series, aka number patterns. You've been doing sequence and series from grade 1 maybe. From as far back as primary school, right? You're just not aware of it, right? You're very good at identifying patterns and noticing what will happen as the pattern grows and continues. We are interested in a couple of things. Can you see a particular pattern and how it's growing or how it's decreasing? Can you be able to predict future terms? Or if we give you a particular term, can you tell us where it is, at what position is it located, right? So there are 3 key things that you need to know: how to work with an arithmetic pattern, how to work with a quadratic pattern, and how to work with an exponential pattern, which is called a geometric pattern, right? Very important for you to understand that. In addition, sigma notation and the concept of sum to infinity, very important. When you know that, you are covered. You can be able to ace this particular section as well, right? So the question that was sent to us starts by, first of all, asking us the following. Calculate the number of terms in the arithmetic pattern below, in the arithmetic sequence below. So apparently, there's an arithmetic sequence, which I'm going to start writing now. It reads as follows. It starts with a 6. It is followed by a -1, and then it's followed by a -4, and it has got dots here, which you guys should know what they mean, and it has got -239, right? -239, if I'm not mistaken. Beautiful stuff. Right, so this is essentially what we're dealing with now. So they say to you, calculate the number of terms. So let's just analyze this question. It's important for you to have the conceptual understanding when you are doing these things, because you'll know what you need to do. What is the question and what is the hint? There are always those 2 things in every math question. There's a question of what we want, and there's a hint of how to find it, right? Find those 2, you will be able to always succeed when you're dealing with these things. The question here is they're asking for the number of terms, right? They want the number of terms. This is what they're looking for. So I know they're looking for the variable n in the context of how we're naming naming our variables in mathematics, right? And then they're telling me that I'm dealing with what? With an arithmetic sequence. So an arithmetic pattern or an arithmetic sequence has got its own formulae, which you can find on the information sheet, right? So let's see what we can do here. First of all, they're looking for the number of terms. So this is as good as asking you if this one is at position number 1, and the other one is at position number 2, and the other one is at position number 3. At what position is this guy? Because this is the last term of this sequence according to what they wrote for us in this case. So they told us that it's arithmetic. This is even good news because you didn't have to be told. You can apparently figure out on your own if you've got 4 terms whether a pattern is arithmetic or geometric or quadratic. Now, if it's arithmetic, it should have what we call a common difference, which means the following. I can actually write down my first value, which is a, and our a value happens to be 6. The common difference is the difference between consecutive terms. Remember, when you're looking for the common difference, you do reverse subtraction. It is this term minus the term before it. So -1 minus 6. It's actually not -1 according to what I'm looking at here. It's +1. Very important. It's not really that visible. It's +1, right? So 1 minus 6 gives me a value of -5, right? And then if I wanted to verify that indeed this is an arithmetic pattern, when I subtract -4 and 1, I must still get the same solution, which means the following. If I take this guy and I minus that one, -4 minus 1 will also give me a solution of -5. Because I'm busy getting -5 when I do the subtraction of subsequent terms, this tells me that indeed this is an arithmetic pattern with a common difference of -5. Now, what we're looking at there is the Tn value, also known as the last term, right? The last term happens to be -239, and we don't know how many terms are being written down in this particular sequence, right? So I'm going to start first of all by writing what you people know. The general term of an arithmetic pattern is Tn equals a plus n minus 1 multiplied by the common difference, right? But what is the term? This general term here is the last term that I'm dealing with. I'm trying to figure out this -239 is at what position. My a value happens to be 6. I don't know the position of the term, but I know the common difference is -5. Please be careful. Use brackets when you're substituting a negative value, because if you don't do that, you'll make a mistake of thinking you're subtracting instead of multiplying. Okay, let's clean that up. Okay, cool. So on the left hand side, we're going to have negative 239 is 6. And then this guy by that gives us exactly negative 5n. And this one by that gives us positive 5. So I want n to be on the left hand side, so I'm going to add 5n on both sides. So my 5n is going to come this side. It's as good as saying you're taking this 5n to the left, or you're adding 5n on both sides. I'm left with 6 here, I'm left with 5 here, and that 239 comes this side, becomes positive 239. Those are all numbers. We can add them. We call them like terms in mathematics. If you sum them up, right, the correct terminology is to say you're summing them up. So what is 6 added with 5? Added with 239, right? What do you get? You get 250, right? So this comes out as 250. And if I proceed here and I divide both sides by 5n is going to be 50, right? If you want to confirm that, just divide that by 5. You end up with an answer of exactly 50. So because I'm getting an answer of 50, I haven't really answered the question. Remember to answer the question. What was the question? The question was calculate the number of terms. So now I'm going to answer and say, Mr. Examiner, we can conclude and say, therefore, there are 50 terms in this sequence, right? There are 50 terms in this particular sequence. A beautiful question, no complications, right? Now, the next question here is the second question, which reads as follows. It says to us here, the third term of a geometric series. Now, you see, we're changing tune now from arithmetic. We're now asking you about a geometry, right? The third term of a geometric series is 18. Okay, let me write that down, right? So the third term of a geometric series is 18. Okay, third term, right, of a geometric, okay, of a geometric sequence is 18. Okay, right. Now what? And the fifth term is 162. Okay, and fifth term, okay, is 162. Beautiful stuff. So the third term of a geometric series is 18, and the fifth term is 162. We want you to find, they say determine, right? Find or determine. Okay. What are we supposed to find? Well, we have to find the sum. We require you to find the sum of the first 7 terms. Okay, the first 7 terms. Oh, beautiful stuff. Where r is less than 0, right? Okay, there's a condition that says where r is less than 0. This condition might work, sometimes it doesn't work, but sometimes it's very important to guide you if you happen to get more than one solution. Okay, so how does this actually work out? Okay, first of all, we are told that the third term of a geometric series is 18. How do you write this mathematically? Right, this thing here, right? The third term of a geometric series is 18. So this is going to look like this. So T3 is equal to 18. Beautiful stuff, right? And then there's a second part here that says the fifth term is 162. So T5 is equal to 162. So T3 is equal to 18, right? And T5 is equals to 162. But the examiner told us that this thing is arithmetic. So what is the general term for anything, geometric? What is the general term for a geometric pattern? Because they told us that this is geometric, right? We know that the general term of a geometric sequence or series is a r to the power of n minus 1, right? So I'm going to use that in order to try and create 2 equations and hopefully succeed to solve them simultaneously to find a couple of important things that will help me to answer the question. What is the question again? The question is asking for the sum of how many terms? The sum of 7 terms, right? So for me to find the sum, I'm going to use the formula of the sum, right? The formula of the sum looks as follows. It says the sum of n terms is going to be a into r to the power of n minus 1 all over r minus 1. Now you're probably wondering, what's the story with all this information? Well, for you to find the sum of 7 terms, you do know the number of terms you're adding, which means you know that your n is going to be 7. But you don't know what the first term is, and you don't know what the ratio is. So that's why the problem in this question will require you to work a lot. It's actually worth 6 marks. That's where the whole hustle actually lies. It lies in you figuring out what is A and what is R. Because calculating a sum is not difficult. It's pretty straightforward. Okay, so the whole thing that I'm going to be trying to do here is figuring out what is A and what is R, so that I can be able to then find the sum of the first 7 terms. Beautiful stuff. So let's go and see what will happen. So on the left hand side here, the story of T3, right? Term 3, when you work out term 3, you're going to say the following. So Tn is AR to the power n minus 1. So the term value is 18. So I'm substituting 18 for term. I don't know what the first term is. I don't know what the ratio is, but I know that my n value is 3. So when I take that 3 and I substitute it where I see n, I'm going to have 3 minus 1, beautiful people. This 3 here, I'm replacing it there where I see n. So 3 minus 1 is going to give me 2. So this is actually going to be AR to the power of 2. Okay, so this is going to be my equation 1. Now I'm going to go to the second part, the one about the fifth term, right? The fifth term. The fifth term, again, Tn is AR to the power of n minus 1. What is the value of the term? The value of the term is 162. What is the first term? We don't know that. What is the ratio? We don't know that, but we know this is term number 5. So it's at position 5. So position 5 minus 1 will give us a value of 4. Right. So this is going to be my equation 2. So I'm going to be very sneaky and cheat this simultaneous. It's actually legal. There's nothing wrong with doing it. So what I'm going to do here is the following. Remember the following, guys? An arithmetic pattern has a common difference. It's about addition and subtraction. A geometric pattern is about ratios. It's about multiplication and division. So what I'm going to do, I'm going to stack these two equations like this and then divide them. But if I was dealing with arithmetic, I was going to try and subtract or add. Subtract is actually the right word. You are going to subtract if it was arithmetic. But because I'm dealing with a geometric patterns are about multiplication and division. They have got a common ratio which talks about division. So I'm going to stack this like these and then start dividing them. Right. So let's see how that looks. I'm going to take 162 equals AR to the power of 4. And I'll take the second one. 18 equals to AR to the power of 2. So what I'm going to do here, I'm going to divide them. So which means equation 2 divide by equation 1. This is a beautiful and legal thing to do. So let's see what will happen. When you take 162 and you divide it by 18, you end up with 9. How nice is that? So I'm getting 9 equals to 8 divided by 8. They will actually give you a value of 1. R to the 4 divided by R to the 2. When you're dividing same basis, you subtract the exponent. So I'm going to have 1 from 8 divided by 8, and then R to the power 4 minus 2, which is going to give me 2. So my R squared is coming out as 9 when I take the square root here on both sides. If I take the square root on both sides, then my R value is going to come out as take the square root here and take the square root. Remember, it's plus minus. So your R comes out as plus minus a beautiful number, which happens to be 3. But again, remember they told you the condition at the top. They said your ratio here can only be a number that is less than 0. That's what the examiner said. They said where R is less than 0. So it means between plus 3 and minus 3, which one are we supposed to take? I can hear someone saying we need to take the negative one. Right. So therefore, your R is equal to negative 3. Now that I've got R, then I can try and find my A value. Where am I going to do that? I can either substitute this in equation 1 or in equation 2. I love equation 1 because it's got a small number, which is 18. Right, and I'm going to do it here. So I'm going to say 18 is equals to A into negative 3 with a square. So we square that on both sides, you're going to get 9. So 18 is A multiplied by 9. Divide both sides, you're going to get an A value of 2. In this case, it doesn't matter whether you were dealing with minus 3 or plus 3. You're just going to get the same A value of exactly positive 2. Okay, cool. So what is going on here? Well, I've got a pattern that has got an A value of 2. That has got a ratio of negative 3. I'm looking for the sum, right, of 7 terms. This is what I'm looking for. Okay, cool. So let's call the relevant formula to use here. So Sn is A into R to the power n minus 1 over R minus 1, where R cannot be equal to not 0, Schofield, but where R cannot be equal to 1, because if it's 1, then you're going to have division by 0, which is actually a problem, right? So I'm looking for the sum of how many terms? Of 7 terms. What is my A value? It's 2. What's my ratio? My ratio is negative 3, right, to the power of n. How many terms are we adding? 7. subtract 1 divided by something beautiful, which is what? Which is -3 minus 1, right? So let's call back the machine. Remember, a calculator is an instrument, not a monument, so you guys should use it, right? So I'm going to have another bracket where I'm going to sub my -3. Be careful with the use of your bracket. Then I'm going to have an exponent of 7 because I'm summing up 7 terms, right? And then let's come down, subtract 1 there, close bracket. Okay, -3 to the power of 7 minus 1, everything divided by my R is -3 minus 1. Okay, what am I getting? I'm getting 1094 as the answer. So my answer here happens to be 1094. So this is the sum of 7 terms of this beautiful sequence. I hope it's making sense and you guys are able to understand what is going on here. All right, the last part of this awesome sequence and series question says the following, right? It says the following. Consider the infinite geometric series, okay? This is number 3, right? Consider the infinite, okay? Consider the following infinite, right? Infinite geometric series. Okay, cool. And they wrote 2 into, they've got p minus 5 plus. They've got 2 into p minus 5 squared plus. They've got 2 into p minus 5 cubed plus, and this thing goes on and on, right? What does this tell us? Well, this tells us that it's going to go on forever and ever until the second coming. Okay, right. Question 3.1 says to us here, for which values of p, okay, for which values of p, okay, for which values of p is the series converging? Is the series converging? Okay, let's stop there. Right. So we've got a pattern which was given to us. In this case, it's not a sequence, it's a series. Again, what's the difference? Sequence is just, as I said, order of numbers that are in this particular order, ordered numbers. But a series is when those numbers are added or subtracted, right? So in this case, it's something plus something else plus something else, right? So we've got them, right? So like I said, there's the question, which is what we wanted to do, and there's the hint that guides you on how to do that, right? So the important thing, right, that you need to understand is the concept behind what you're dealing with here. The key word that I see when I look at this is the word converge, right? And you've got to ask yourself a simple question. When a pattern converges, what does it mean? A pattern converges if it has, right, if it has a common ratio, number 1, which means it must be a geometric pattern, right? If it's got a common ratio, right, if it's a series that has a common ratio, such that that ratio lies between -1 and +1, which means your R value cannot be a number more than 1 or less than -1. It must be positive 0, something or negative 0, something. Very important. Okay, so that's what I'm going to base my solution on. The keyword. What's the keyword? The keyword is the word converge. So this word must mean a whole lot to me, right? So what's the scale of convergence? The scale of convergence is this one, right? If this is -1 and this is 0 and this is 1 and you've got other guys here, right? And more other guys here, right? My series will only converge if its common ratio is any number here, right? It can't be more than 1 or smaller than -1. So it has to be a ratio between +1 and -1. That's what convergence looks like graphically, right? It looks like this. You've got to have the concept in your mind. You've got to understand what convergence means. So which means if I'm dealing with a pattern that has got a ratio that lies between -1 and 1, it means its sum to infinity can be computed because it goes closer. The more you keep adding the terms of that particular series, they keep getting closer and closer towards a particular value. And you can find the total sum of all of them if they were to ever get to infinity, right? So now, this is actually what is going to happen. So anything that lies here is actually where the series will converge. But if you have something that is on the right-hand side of this, then that's not convergence. Or if it's on the left-hand side of that, then that is not convergence. Sometimes we talk about a series that is going to diverge. And that is possible if you're dealing with those kinds of situations, right? So which means the following. My starting point is the following. I'm going to say to the examiner, well, for my series to converge, the R, or the ratio, needs to be a value between -1 and 1. Okay, but what is this R? The R value is what you get when you divide term 2 and term 1. Where is term 1? This here is my term 1. This here is my term 2. This here is my term 3, right? The common ratio is going to be found when you take term 2 and you divide it by term 1. Okay, let's do that, right? So my R is going to be T2 divided by T1, which is going to be 2 into P minus 5 squared divided by 2 into P minus 5. The 2's will cancel out because 2 and 2 divide each other out, and then there's 2p minus 5 squares on the numerator, there's one of them on the denominator, so that just leaves us with 1p minus 5. Beautiful, right? So that is my R value. P minus 5 is what R is. And if you go back to the pattern, you can see that's the only thing changing. It was p minus 5, and then it suddenly became p minus 5 squared. And then p minus 5 cubed. What does that mean? It means the only thing changing is p minus 5. So that p minus 5 is what they are multiplying by as they are moving from one term to the next term. Makes sense. Absolute sense. Right. So now I'm going to come back and say, okay, examiner, I just found my R value. So which means this p minus 5 needs to definitely lie between 1 and minus 1. Now we need to solve for p. Okay, which is as good as saying we are doing a simultaneous equation here. So I'm going to add 5 everywhere. I'm going to add 5 everywhere. What do I mean? You add 5 here. You add 5 inside. You also add 5 at the end, right? When you add 5 on -1, what do you end up with? Well, you end up with exactly 4. In the middle there, 5 and 5 cancel each other. You just left with p. And on the right-hand side, 1 plus 5 is going to give you a value of 6. So all p values that are between 4 and 6 will make this particular series to converge. Awesome stuff. And then the last part of this says to us we need to now find the sum to infinity if p is 4.5. Right. So now if I was a silly examiner, I was going to give you a lot of p values. I was going to say when p is 4.5 or when p is 10. So I want you to make the connection there to see which one of these p values does not make sense. According to what we just found now, p can only be any number between 4 and 6, excluding both 4 and 6, right? So any number between there will make this particular series to converge. But p, of course, cannot be 5, because if it's 5, we're going to have a problem. The whole pattern is going to look as the same number, right? Be careful of that. Now, they say p can be 4.5. So what I need to do is just call the sum to infinity formula, find all the variables that I needed, substitute, and then voila, I'm going to get my answer from that. Very simple, no complications. Okay, cool. So you told me that p is 4.5. Let's see what will happen. The first part here, you had 2 into p minus 5, according to the pattern. This is my first term. The ratio is also p minus 5, right? What are we looking for? We're looking for sum to infinity, right? Why do I only need a and r? Well, it's because the sum to infinity formula says a over 1 minus r. Where do we get this? This is available in the formula sheet, aka the information sheet, not that aka, right? Okay, cool. So I now know what p is. They gave me 4.5. Any number between 4 and 6 could have worked, but the examiner is interested in 4.5. So I'm going to sub that here. This is 2 into 4.5. This is how they wrote it. I'm going to write it like that because I want you to learn something, right? And then again, p is 4.5. So 4.5 minus 5 equals 2, right? So you people don't know how to use your calculators. Not all of you, of course, but some of you guys struggle to use the calculator whenever you're dealing with mixed fractions, right? If you have to create 4.5 in your calculator, you don't press this fraction, and then you press the big arrow and force a 4 there. And then try to put a 1 here and then try to put a half. That's not 4.5, because if you press the equality sign, it gives you a 2, which tells you that you didn't try to work out a mixed fraction of 4.5. You are multiplying 4.5 because half of 4 is 2. That's wrong. That's not how you do a mixed fraction. There's a button for the mixed fraction in your calculator. It's in yellow. So you must press shift first and then press that yellow button for the bracket, for a fraction. You'll see it's got 3 boxes, and then it must give you 3 boxes like this. That's how you compute 4.5. Please keep that in mind. So I'm going to put 2 here. I'm going to put a bracket, right? Because that's what we were given. And then I'm going to have my p value, which, like I said, shift fraction. I've got 4 here, and I've got 1 here, and I've got 2, right? And I've got minus 5, right? This is just for the benefit of those that might want to use the mixed fraction instead of converting it to 4,5, right? And then you end up with a solution of exactly -1. So my A value apparently is -1. So let's go back to P. P, what is P? P has to be negative. Let's see, shift fraction. I've got 4, and I have 1/2, and I need to subtract 5. What do you end up with? We end up with -0.5. Okay, minus 1/2. So I'm good to go. I've got A, I've got R. I can find my sum. My A value is -1, my 1 is 1, and my R is -1. Be careful when you're using your brackets. Be careful to always check if you're not making mistakes with signs as well, and everything should come out quite the way you want it to do. So my A value fraction is a -1. Okay, -1/1 minus open bracket, -1/2, right? Not 3 Schofield, but 2. And then you close your bracket there. And when you press the equality sign, you end up with an answer of -2/3. So the answer comes out as -2/3, right?